My name is Dima Kovalenko. A little bit about me. I've been a software tester since about 2006, maybe a little bit earlier, but I have not tested these slides, so they're broken. I've been using Docker for about 2 years now, and I'm not an expert, but I have some experiences I want to share. And at some point in the past, I wrote a book. It's Design Patterns for Selenium. It is this. I wrote it for QA people who are not necessarily programmers, to introduce them both to Selenium, but also to some basic design patterns of how to make your code not be bad, reusable and modular and all those things. So if you're interested, you can get it on Amazon. So this talk is going to be a little bit about virtualization, a little bit of Docker, Jenkins, and the plugin that my friend wrote called .ci. So let's see. Let's talk about the motivation for this talk. This is a true-ish story. Some names and faces have been changed to protect the identity, my identity, because I was the one to screw up. So when I started this new job, the setup was pretty simple. It's a Windows .NET shop. We had virtual machines. All of them are Windows 2008. The machines would compile and run some UI tests. And there was the build process would start off with somebody committing something to SVN. First machine would pick up all of the .NET, Python, and any other third-party libraries that we had. That it would combine them together into a 1 GB zip file and deploy it to a staging area so that a bunch of about 200-300 Windows nodes then can download it and run some UI tests against it. There was about 20,000 tests, and they were all very slow, and sometimes it'll take 10 hours to run all the tests. So all of the machines were created manually, which is a red flag. If you're starting a job and we have 300 machines that all were individually created, don't take the job. Go look for something else, I'm telling you. There was only one machine that could compile the code. Nobody else could. Nobody else's laptop or computer could compile the whole code base together. They individually could compile just the Python or just the .NET or just the JavaScript, but none of the machines had the combination of everything. So it was only one virtual machine that can create a usable artifact that will be deployed to production. Again, big red flag, danger. There was no documentation on how that machine was set up. So the guy who initially set it up, he left a year or two ago, and the other guy who was helping him, he just doesn't remember anything. So nobody knows what this machine is. It's just this magic, scary machine. So need I say it's not recoverable because nobody bothered setting up backups. So anybody wants to guess what happened next? About 3 months on the job, the machine crashes. And this is the only machine that can make a production artifact. And we owe clients some new features that were promised. So when the owner of the company is standing behind you, watching you trying to fix this machine that crashed, because his customers were yelling at him, the only thing that is going through your mind is, yeah. Shoot, I should have looked up for a new image. Anyways, it was a very scary situation. It took about 2 weeks to restore a machine by finding little bits and pieces, and even then, the restoration was go to one developer's machine, copy a folder, and go to another and copy these two folders together, and this folder, and by the end of it, you could start to compile again. Speaking of a side note though, backups, there's no such thing as too many of them. In the setup node that was working, the problem with it was that there was no backups. Later on, with the Jenkins master, it had backups, but as always with backups and tapes, when something crashes, your backups don't work. I mean, GitLab just had this experience a couple of weeks ago, and that was fun. So luckily, in this case, I manually set up a couple of backups for Jenkins server where all of the job configs and all the XMLs, they were backed up regularly to Git, and that way I was able to piece together the instance. We lost some builds, we lost some artifacts, but all the jobs were back and we could start to compile again and rebuild any artifacts that are missing. So that took about a day to do instead of 2 weeks. So backups are your friends. Anyways, the lesson that came out of this experience was there is no such thing as, this is just a Jenkins test node. There's no such thing, because if you have some sort of a deployment strategy where you're gonna run all the tests on a machine and then push out the artifact to production and you need to have everything tested, your test nodes are not test nodes, they're production nodes. So treat them as production nodes. If it's not documented, if the node, how you set the node up is not documented, the node does not exist, it'll be gone. Practice disaster recovery. Just pretend that the machine crashed and you have to go and recreate it from scratch. Do it on a regular basis. Do it once a week. And keep your documentation as code. That's the Martin Fowler principle of agile development. You don't need to have a lot of wiki pages that describe everything, and then just have some code that automatically sets up your nodes. So that's it, I'm out of here. I'm kidding. So let's talk about the nodes and virtualization. We started to use, after the whole disaster, we started to use Chef to create the Jenkins instances and nodes to actually recreate. And right now, if I want a brand new node, it will take about 30 minutes to an hour to go from no virtual machine to a machine that can run our tests, compile, and give us good results. The problem with Chef, though, is that it's large. You need to have a Chef server, you need to have a bunch of recipes. If you're gonna customize the operating system, you have to write a lot of Ruby to do it. And on top of that, Chef is a little bit slow. So it's great if you're gonna have some nodes that you need to recreate once a week maybe, but if you wanted something faster, Chef is not necessarily a good starting point for you. Here, in comes Docker, which is much more lightweight. All the configuration for this stored in a single Docker file, and it's free. So the way that Docker works, for those who don't know, is a little bit differently than virtual machine. If you have virtualization such as VMware or Parallels or VirtualBox, you basically have a full operating system that sits on top of your host machine. And the full operating system needs to have its own RAM and its own CPU cycles and everything. Docker is a little bit different. It borrows and shares resources with the host machine. So to run a virtual container, a Docker container, an instance of your virtual machine, you do not need as many resources. So instead of having one host machine and maybe 2 virtual machines in VirtualBox, you can have up to 10 or as many as your RAM and CPUs will allow you to have. So I want to have a quick introduction to a Docker file. Don't worry, this is not scary. Let's see. So this is Docker Selenium. Excuse me. This is Docker Selenium Project. Wow. Everything that can go wrong will always go wrong during the presentation, so be ready for that. Anyways, this is the Docker Selenium project that is inside of the Selenium HQ GitHub page. You can see that it has a couple of examples for you to use. You have the hub for Selenium Grid, and then you have nodes, different nodes. You have the Chrome node and Firefox node. So let's take a look at the Firefox one. Everything is stored in this little Docker file. It does refer another Docker file by saying, by the way, is this readable? Bump it up. Okay. Okay. It does refer to a base node, which is the virtual machine that was set up. It's an Ubuntu box that was set up. And then it allows you to define fun things like version of the Firefox to use. And if you're familiar with Ubuntu, all these commands are pretty straightforward. There's no different language that you need to learn. You don't need to do Ruby methods or anything like that. You just do simple installs. If you need to install a browser, you install a browser. If you need to install Java, you install Java. This gives you a lot of freedom to customize how your host environment is going to run. Let's see. So everything is relatively straightforward. Let's see. So for example, right now my port is completely closed. There's nothing running on it. And then I just bring up oops. One sec. So I just stood up a Selenium Grid hub, and you can see it's up and running. This is how long it typically takes to create a virtual machine once you have all the stuff pre-downloaded. So imagine a world where your test wants 10 instances of Firefox 51. By running Docker, you can create those in just a couple of seconds, and at this point, you're able to just go straight and dive into the testing. You don't need to deal with Selenium Grid as much as everybody loves the grid. You don't have to deal with it anymore. You just create what you need on the fly. If your test needs to run against Chrome and Firefox at the same time, or you want to run against the previous version of Firefox, all you have to do is just go back to the Docker file and change the version you want. Just update the settings that you want. And the best part about it is it's so lightweight that you can actually have it up and running on your laptop, and you can, when you're developing tests and you're writing tests on your machine, you can connect to an instance of Docker from your machine. So this is a Ubuntu a project that I found on GitHub. So it's just a very simple Docker with VNC server, because all the other the default things that are on Selenium HQ, they're headless. But I personally like to look at the browser when I'm writing a Selenium test. And so I'm just going to stand this container up. Okay. And my container got stood up. And oh, it comes built in with that little VNC server that you can just open up in your browser. And you have a virtual machine that you can run against your Firefox or against Chrome or whatever you're doing. So this will allow you to test forward and backwards compatibility before you even have to push anything into production or into master branch, or before you push it up to CI. If you need to run as you know, every time Firefox updates, it will break half of your code. That's just a given. So this will allow you to, if you have a locked version that is in your master branch, you can test it first against the latest version of Firefox, push it up, and you're not modifying your host machine, and you're not modifying any other machines that are in your Jenkins cloud. So relatively simple, relatively fast to use. Let's see, next slide. So that's the URLs for the Docker Selenium and the URL for the Docker Ubuntu VNC. You can go and merge those files that way, because in any way you want to. So how would the setup, if you're going to use Docker to test either your Selenium tests or even your low-level GUI tests, the way it would work is you would install Docker on all of the nodes in Jenkins that you have. You would put the Docker file into your repository, and then when the build kicks off, you will just call a single shell file. And the shell file then would go and stand up the container just like I did, and then trigger the tests on in the container. The beauty of it is you can, for example, if you're really trying to work on upgrading from Java 7 to Java 8 on your backend, and you need to test both, you can just set up 2 Docker files, one for Java 7 and one for Java 8. And every time you run a test, your shell script will just call Java 7 Docker file and Java 8 Docker file, and you can have those running in parallel without actually having to hurt the host machine. The reason that we went with this solution also was right now we have about 11 teams, and each team has completely different requirements. We have one team that is programming in Python 2. We have another team that is programming in Python 8. We have a Java team, we have a Node.js team, and we have a Ruby team. So before I started to work at this company, what they did is each team would have their own little build node in Jenkins, and that build node was set up and maintained by them. Somebody had to, every time they needed to do a patch test or an upgrade to the container, to the host machine, somebody actually had to go and manually update that. But right now, each team has the rights and privileges to mess with their own installation without having to contact any of the developers or any of the operations people. They just say, hey, I need to forward test this. Let's just update it and push it up. If it passes, let's merge it into master. With a manual setup, if you were to set this up yourself, it would not take that long, and there's a little bit of learning curve, but otherwise it's not that hard. A friend of mine wrote a plugin called .ci, and the thing, what it does is it integrates Jenkins, Docker, and GitHub all together, where user pushes something to the GitHub repository and creates a pull request. GitHub then triggers the Jenkins build. Jenkins then stands up a Docker container and notifies GitHub of passing your failure, and it notifies it directly onto the pull request. That way, when you have a pull request and you see every single commit that went into that branch, every single commit is marked with X or check to show you, okay, it was failing, and then this commit made it green, and now we can merge things. So we're going back into the whole trunk-based development and giving developers the ability to easily test on the CI before they have to commit to anything. And if the builds are failing, or we find out that the feature is not needed anymore, that you just delete the branch and you have not modified any of your Jenkins nodes. It's all available. So the next exciting thing I am excited about is there's, I think it's still a beta, stage, but it's Docker for Windows. And the idea there is actually pretty simple. You will need Windows 10, but it will work very similarly to how Docker is set up on the for Ubuntu and CentOS and other Linux distributions. So it's Microsoft Nano Server. I have not had a chance to play with it, but it looks promising that if we can stand up Windows containers, then at some point we will not need Selenium Grid altogether, because we will be able to stand up a couple of IE containers here, a couple of Firefox containers, and just do it on the fly. As long as you have resources to run your test, you can always throw more RAM or more CPUs and just run things on Windows, and Windows now becomes a more Linux-like environment. All right. Let's see. I wanted to look at the .ci. So .ci is a Java Jenkins plugin, and it's if you ever used Circle or Travis, it has a very, very similar interface. You just tell it where the Docker Compose file is, and tell it what to do with each run, and for example, run npm test. The cool part about Docker also is there's another level above it called Docker Compose. And what that allows you to do is it allows you to set up multiple machines and tie them all together. That way you can recreate production-like environment. You can have a Docker container that is just running your MySQL database, and Docker container that just runs the API, and one that just runs the web front end. All of it being tied together, you're no longer running everything on just one machine. When your tests, your Selenium tests are running against it, they will be running in production-like environment with all the communications and all the gotchas taken out of it. So Compose is great for tying all these things together. Let's see. Okay, what else can I show you? So, quick review. So one day I'm hoping to see no more Selenium Grid. It's just ever since I started to work with it, I'll be honest, it's been one headache after another headache. One of the biggest problems with Selenium Grid is always having to restart the nodes. If we put things into a container, we don't have to restart the nodes because you get a clean node every single time you run the test. All of the things are pre-installed. There's no cache in Internet Explorer. There's no cookies or anything. It's just clean. It will be a beautiful world, and I would like to start working on this as soon as the Windows Docker becomes a little bit more mature. So as I said, before we started to Dockerize our builds, we had just a bunch of machines that were created completely by hand, which was a big problem because, yes, people kept on leaving, new people kept on coming in, and nobody knew what was where and how it worked together. Each node was dedicated to a single team, and you could only run one test at a time because you only had one node, and each node had its own database and its own connection, and you could not install multiple things on a single node to run things in parallel. Developers and testers were absolutely the weakest people in this whole situation, because once the node was set up, it was so precious that it was handed off to the operation people to watch over. If you wanted to upgrade to a new version of anything, or you needed to run a Windows update on any of those nodes, you would actually have to file a ticket and wait a week or two for somebody to actually pick it up and fix things for you. And after this, all of our VMs are now are version controlled in the repository. Developers can set up any crazy environment that they want to without having to ask for permission, without having to talk to anybody. They can throw away an experimental branch as fast as they can create it. Right now we have 4 Linux nodes. They're about 4 CPUs, about 16 gigs each, and they are running 11 teams, and between the teams they have multiple repositories and multiple modular products. All of it is running on 4 nodes. It's relatively fast. The stand-up and tear-down is just 30 seconds to a minute. It depends on how much you actually keep things in cache. And on top of that, if you set up a Docker repository in your company so that the images that you create could be uploaded, then you can create a stable version of CentOS 7 with Java 8. Everything is pre-created. We're talking about instant stand-up time. It doesn't have to go and compile anything, which gives us a lot of control over the whole environment. And as a tester, that was my biggest problem with a lot of the companies I used to work at, where you come in and you have absolutely no control over your environment, and you have to go and you have to say, pretty please, somebody fix this, somebody please update this. Whenever something would go wrong, you could not replicate it. Now, when something goes wrong, I can just take the container that I was running on my machine and I can save it, and I can give the developer the container that everything was running in. And they can go and stand it up on their laptop and see the virtual machine in the same state as it failed. If you have to do the same thing with the VMware or Parallels or whatever, we're talking about 10, 20 gigabyte images. Here, the container is 100 megabytes. It's easy to put on a thumb drive and just go and give it to a developer and say, here, fix it. Something's wrong with here, figure it out and fix it so that they can actually reproduce the issues. The whole, I can't reproduce this bug, or it works fine on my machine. It's one of the biggest problems and pet peeves I've ever had. So just giving them something like that. One of the plans I was thinking of, if we were to get rid of Selenium Grid, is just to have, every time the Docker Selenium container stood up, we just start recording a video of the test run, and then you decide what to do, whether you want to keep the video or not. I mean, the options are quite endless, and you can go and start implementing them and contribute back to the Selenium community. There will be nobody stopping you. Actually, we're asking for help. So please don't be shy. All right, I think I ran a little bit fast, so let's have some questions, I guess. No questions. Yes.
Hi, maybe a simple question, but did you follow the Microsoft? What are those plans to roll out the Docker with graphic windows?
I have, honestly, from what I've read, Microsoft, since the new CEO, has been changing a lot of the things that they do. So they've been becoming a lot more Linux-like. They recently allowed Bash to run natively on Windows, and they seem to be very committed because all of these updates and whatnot are published on their Microsoft blog. So it looks pretty promising that they will actually follow through and give us a working version of Windows. I'm not sure when that will happen, but I'm literally just waiting on the edge of my seat. So that's, yeah. There's a guy right there.
Hi, thank you for speech. What about mobile operation system? Do you have some experience?
With the, can you
With
repeat?
Docker with mobile, with Android?
Android, okay, yes. So in my previous job, we set up a Docker swarm. And a Docker swarm is basically, you have a bunch of possible VMs that are sitting there waiting for something. And then when a test comes over, it's similar to Selenium Grid, where you have a bunch of nodes and you just ask for one and you grab whichever one is available. We had Android SDK installed on them. And they did run Android tests both headlessly and in the Android, whatever, the virtualization that Android has. It's a full operating system, so if you can get something to run on a Linux computer, you can run it inside of a Docker. So there's absolutely no limits in that way. I guess there's no more questions. All right, thank you so much.